Hello and welcome to Advanced Algebra. In this lecture, we're going to do more of what we did in the last lecture. We're going to combine function with a composition. Let's go over the first example. So I'm going to do example 1 and you will do example 2. Here I'm giving you two functions f and g and I want you to find g of f. So start by writing the definition of this function. G of f applied to x, g of x, is by definition g of f of x. So that means you take f of x and you plug it in g. So you told me in class that you rather change f of x first. So this is g of, what is f of x? 2x minus 3. 2x minus 3. So I take 2x minus 3 and I plug it inside g. What does it mean? I'm going to write g of x. What is g of x? G of x is x squared plus 1, right? That's g of x. But here it's not g of x, it's g of 2x minus 3. So I'm going to rewrite g of x, and anytime I have an x, I replace it by 2x minus 3. So g of 2x minus 3 is 2x minus 3 squared, right? This is the x squared, and then plus 1. I only have one x here. That's it. That's done. So let's simplify this. So this is 2x minus 3 times 2x minus 3 plus 1. Let's FOIL this. So this is 4x squared, right? You FOIL like this, right? And then we have minus 6x plus 9 plus 1. Therefore, the expression for g of f at x is, so what is it? 4x squared. Then we have 6x and 6x, that's negative 12x. And then plus 9 plus 1 plus 10. That's it. That's the expression of the composition of g of f. Please do number 2. You're going to be doing every other examples. Let's go over number 3. Alright, so here I'm given only one function, but I have to compose it with itself. Okay, so how do you do that? So h of x by definition is h of x. So you plug h of x into itself. So let me replace this h of x here. So it's h of, what is h of x? 1 over 1 minus x. Alright, now please watch out here. I'm gonna plug 1 minus x inside h of x. Okay, so every time I have x, and here there's only one x, right? Every time I have x, I'm gonna replace it by 1 over 1 minus x. So let's write this. It is 1 over 1 minus, and here it's not x, but it's 1 over 1 minus x, like that. Okay, how do you simplify this fraction? You got a fraction over a fraction, right? This is a main fraction bar right here, but there is another fraction at the denominator. How do you simplify this? So here's a way to do it that is fast and safe. I would look at the denominator I have. At the top, I don't have any denominator. The top is just 1 over 1, right? And at the bottom, this is my only denominator, 1 minus x, right? So I would multiply both sides of the main fraction by the denominator 1 minus x. You will see what it does. It cancels every denominator, 1 minus x, right here. All right. So now, please pay attention. You have to distribute it, right? So there's nothing to do right here. 1 times 1 minus x is just 1 minus x. But here, you have to distribute it to that, to the 1, and to this fraction right here, right? So what do we have? At the top, we have 1 minus x. What about at the bottom? Well, we have 1 times 1 minus x, so that's just 1 minus x. And then, what's that? So here, I'll take it aside. But if you have 1 over 1 minus x, and you multiply this by 1 minus x, which is what we have to do, right? What's going on here? It's a multiplication of two fractions. The fraction on the right is 1 minus x over 1. And how do you multiply fraction? You multiply numerators and you multiply denominators. So it is 1 minus x over 1 minus x. So that is just 1. Okay? So careful with the negative sign in front. So minus 1. That's it. It's very simple, the expression we have. Therefore, what do we have? The composition is h of x is, so at the top, 1 minus x. At the bottom, 1 minus 1 cancels, negative x. And here, I wouldn't leave a negative sign right here. Instead, I'll bring it to the top and change the top. So this is the opposite of 1 minus x is x minus 1 over x. Again, let me remind you of the very important rule. The opposite of a over b is the same thing as a over the opposite of b, which is the same thing as the opposite of a over b. Alright, so I've used this rule and I went from right to left. Negative sign at the bottom went to the top. Okay? Alright, please do the next example. Let me do the last one. I'm going to do number 6. You will do number 5, please. Okay? So here are two functions and I want f of g. So f of g of x is f of g of x right here. So you have to plug g of x inside f. So this is f of, what is g of x? 2x over x plus 1. Alright, so now I'm gonna write f, which is right here, and every time I have an x, I'll replace it by 2x over x plus 1, right? Alright, so let's write f. F is x, so 2x over x plus 1 over 2 minus x, so 2 minus, and here 2x over x plus 1. Alright, that was not too painful. Now this is a fraction over a fraction. Again, don't lose track of your main fraction bar. It's this one right here. We're going to do the same thing that we did on the previous example. My common denominator is x plus 1 right here, right? X plus 1 and x plus 1 right here. So I'm going to multiply both sides of my main fraction by x plus 1 right here. So what do you have at the top when this multiplies this? Well, the denominators will cancel, right? You will cancel the denominators. Don't forget to multiply at the bottom too. And here, you're gonna have to distribute it, right? Okay, so at the top, what do you have? 2x, because the denominator here will cancel with x plus 1 right there. At the denominator, what do you have? 2 times x plus 1 right here, so 2 times x plus 1, and then minus, right? A minus times a plus is a minus, and when this x plus 1 is going to multiply this, the 2x plus 1 will cancel. Let me show you that right here. Look, if you got 2x over x plus 1 and you multiply this by x plus 1 right here, so this is x plus 1 over 1, you should simplify before you multiply. So what's left is 2x. Like that, okay? So, what is that? This is 2x over, so let's expand this right here. So this is 2x plus 2 minus 2x. Alright, so 2x minus 2x, they go. And we have 2x over 2. And here, of course, it will simplify. Therefore, what was the name of the function I was looking for? F of g. Therefore, f of g of x is just x, and we will see later that this is actually an important property, okay, an important remark. All right, do the examples I have not covered in this lecture. Thank you for watching.